Okay, now let's try to define the definition of independent events from this investigation. As we see before, no matter the first round is red or white marbles, it doesn't affect the second round, right? Because no matter what color we take from this box, we always replace it before we do the second drawing. That's why it doesn't change. Actually, the condition here doesn't change. That's why uh, here the probability is just the same. That's what we call as independent events. So two events A and B are independent if the occurrence of A doesn't affect the occurrence of B. So here as we have the conclusion here, we can say that if A and B are independent, or PA and B, or we also can denote it as PA intersect B equals to, so when we have this W and R, it is PW times PR. So because here we have A and B, so it is PA times PB. This is what we call as multiplication law of probability. So remember, before you use this formula, you need to check, are even A and B independent events or not. If you want to check are even A and B independent or not, you can just see if the occurrence of event A doesn't affect the occurrence of event B, it means they are independent events, and you can use the multiplication law of probability here. Now, what if the events are not independent, or we can say dependent events? Actually, we can just remember that we will have independent events if the experiment is with replacement. And then we will have dependent events if the experiment is without replacement. Let's just investigate the same problem here. We want to find the probability of WR, but the case is without replacement. It means after we take the red or white marbles from the box, we will not replace it. So it means the occurrence of event A will affect the occurrence of event B. Okay, let's just try to draw the tree diagram for that experiment. So we still have the first round and then the second round. So for the first row, of course, we still have R and W. It doesn't change, right? For the probability also, it is still the same. The probability of getting R from this box is still 4 over 7. 4 over 7. And then of getting white, it is still 3 over 7. And then because the case is without replacement, it means if we already draw red marbles from this box, we just have 3 red marbles and 3 white marbles, right? So the possible outcomes for the second draw, it is still R or W, but the probability is different now. For the probability R now is 3 over 6 or 1 over 2, and then for white marble also 3 over 6. So when we draw red marbles for the first experiment, for the second experiment we will have 3 over 6 for red marble, and then probability of white marble is 3 over 6 also. It is if the first row is R. Now what if the first row is white? If the first row is white, it means the second row is still R or white, right? But now the probability of drawing R from this box is 4 over 6. 4 over 6, and then for white is 2 over 6, or we can just simplify it later. Let's say this is example 1. So from example 1, but the case is become without replacement. So if example 1 become without replacement, we will have that the probability that the first marble drawn is white, and then the second marble drawn is red, it will become. So basically it is just the same concept with here. After we've defined all of this, now we will have PW. Here is white 3 over 7, and red is 2 over 6. So it is 1 3, so we will have 1 over 7. And then if we want to find the probability of R and R, it means 4 over 7 times 3 over 6. Just the same concept, but the difference is in the probability. So the conclusion is, if we have independent events, we can just use this formula directly. Remember that if the experiment is with replacement, we will have independent events, and then if they are without replacement, we usually just have dependent events. So now for independent events, let's try to do it without drawing the tree diagram. So find the probability that the first marble drawn is white and the second is red. So basically, without drawing the probability, we knew that PWR equals to PW intersect R equals to PW times PR. So it is equals to PW. We have 4 red marbles, and then 4 red marbles, and then 3 white marbles. It means PW is 3 over total 7 times 4 over 7. It is 12 over 49. So that's it. And then what if we want to find, let's say we want to find P, the second row is red. What is the probability of the second row is red? The second row it is red. It means for the first row it can be red or white, right? How to find the probability? It means that what? It is, we can just rewrite it become P if the second row is red. So let's say and red. The first one is, the second row is R. So the first row it can be R or white. So it will be equals to P R or W times P R. So we knew that they are mutually exclusive events, right? They cannot occur at the same time. So it will become PR because this is R. So PW times PR. So PR is, what is PR? Our case is 4 red and 3 white marble. So PR is 4 over 7 plus 3 over 7 times PR. PR is 4 over 7. So it is equals to 4 over 7.